Okay, so let's go ahead and take a look at this lesson. So we're going to talk about the definition of a limit. So we're going to look at limits and continuity and the subjective. So we say that if f of x becomes arbitrarily close to a single number L as it approaches x from C from either side, then the limit is equal to L. So we read it as the limit of f of x as x approaches L is C, meaning that the left side limit is equal to the right side limit, which means that it's overall equal to that number. Left side and right side limits have to be equal to each other in order for this limit to exist. And there's some rules. There's some theorems on limits. When you have sine of x over x or cosine of x minus 1 over x. Some common techniques for evaluating limits are substitution directly, factoring and simplifying, multiplying by the conjugate, or using a graph or table. So, when I look at example 1, plugging in 5 doesn't give me 0 in the denominator, so I'm just going to go ahead and do it. 3 times 5 plus 1, square root of 16, which is 4. Again, I can plug in pi because it doesn't give me 0 in the denominator, so 3 pi minus the sine of pi. The sine of pi is 0, so overall, this is 0. Example 3, I can't just plug in 2 because 2 gives me 0 in the denominator, but I can go ahead and factor my numerator. So this is the limit as t approaches 2 of t minus 2, t minus 1 over t minus 2. And your t minus 2's cancel out. So now I can plug in 2. So 2 minus 1, which is 1. Again, factoring. Limit as x approaches b, x to the 5th minus x to the b, x to the 5th minus b to the 5th, x to the 5th minus b to the 5th, and x to the 5th plus b to the 5th. And my x to the 5th minus b to the 5th cancel out. So I'm left with the limit, x approaches b, 1 over x to the 5th plus b to the 5th. And because now there's no issue with plugging in b in for my x, so I get 1 over b to the 5th plus b to the 5th, which is 1 over 2b to the 5th. Example 5, I'm going to use my multiply by the conjugate trick. So multiplying by the conjugate means I take what's in my numerator or in my denominator, but I switch the signs and multiply the top and bottom by it. So I'm switching the sign in between. Which you could do the box to multiply it out, or you could use FOIL. So the limit t approaches 0, t plus 2 minus 2 over t times root t plus 2 plus root 2. So that gives me t, so the t cancels out. And I'm left with the limit t approaches 0, 1 over root t plus 2 plus root 2. So now I could just plug in 0. So I get 1 over 2 root 2. Okay. Next is example 6. Example 6, there's really nothing I could do, but this is a vertical asymptote. So when I take the limit, x approaches 3 from the negative side, and I look at the graph of this, I'm actually going to get negative infinity, and we'll look at the graph in just a second. And then we'll get positive infinity coming from the right. So now let's take a look at Desmos. 1 divided by x minus 3 And what you notice is, approaching it from the left, you're going towards negative infinity, and then approaching from the right, you're going towards positive infinity. So overall, we say that this limit does not exist. If we have x approaching positive infinity or negative infinity, we call this a definition of a horizontal asymptote. So what we do is we take the ratio take your highest exponent of x in the denominator and divide everybody by it. And then what you get is 6 over 2, which is equal to 3. Do the exact same thing here. Limit x approaches negative infinity, 3x over x cubed minus 10 over x cubed, 4x cubed over x cubed plus 5 over x cubed. And what you actually get is you get a situation where you have 3 over x squared in the numerator. So overall, that limit is going to be 0. Take this one, the limit as x approaches infinity. 1 over x minus x squared over x divided by 10 x over x plus 7 over x. And what you're actually going to be left with in the numerator is you're going to be left with your 1 over x minus x, and as x approaches positive infinity, this is going to approach positive infinity. To determine the horizontal and vertical asymptotes, so from a previous class, the vertical asymptote is when you set the denominator equal to 0. So you get x is equal to 2 is your vertical asymptote. And then limit x approaches infinity, 3x plus 5 over x minus 2. Limit as x approaches infinity, 3x over x plus 5 over x over x minus 2 over x. So you get 3 over 1, which is 3. So your horizontal asymptote is y is equal to 3. Okay, definition of continuity we've talked about before. Left side and right side limit have to be equal to each other, and it has to be equal to f of the point. So here's a rule of discontinuity. Bug walks along the graph, falls through the hole, rule of discontinuity. Jump discontinuity, 2 bugs will never meet. Normally with piecewise functions is where you get jump discontinuities. Vertical tangents are very similar to vertical asymptotes, but they do have something different, and that is the derivative is equal to 0 gives you vertical tangents. Example 11, find the points of discontinuity of the function. So you'll factor this. So x is equal to negative 1 and 2 are vertical asymptotes. Which are also your discontinuities. Determine the intervals on which the graph is continuous, which means that this has to be equal to this. So that means that the limit as x approaches 2 of x squared plus 3x minus 10 over x minus 2 has to be equal to 10. So we can factor this. Limit x approaches 2, x minus 2, x plus 5 over x minus 2 is equal to 10. So this is continuous everywhere, then this is going to be equal to each other. And we don't know that yet. So we can cross those out. And then we get 2 plus 5 is not equal to 10. It's equal to 7. So that means that it's continuous everywhere except for when x is equal to 2. So f of x is continuous on negative infinity to 2 union to infinity. For what value of k is the function continuous at x equals 6? So that means the limit x approaches 6 from the negative side of x squared minus 2x has to be equal to the limit as x approaches 6 on the positive side of 2x plus k. Which means that 6 squared minus 2 times 6 has to be equal to 2 times 6 plus k. So 36 minus 12 has to be equal to 12 plus k. So 24 is equal to 12 plus k, so k is 12. And then the last example, here's my function here, and what value could b be where f of x equals negative 2 has no solution. So let's just graph this for a second. That's the easiest thing. This requires no calculus whatsoever. So 0, negative 4 is here. Here's 5 and negative 4. So if here's x equals 3, so if I was 3, 3, I would have 2 solutions. So that one is out. If I was at 3, 1, I would also have 2 solutions. It's because it crosses the x-axis twice. So that would be out. At 0, I would be at 1 solution. Or no, I'm sorry, we'd still be at 2 solutions. Because I want x equals negative 2. So I'm looking at how many times it crosses the line x equals negative 2. If I had negative 2, it would be at once. So that's 1 spot. So it has to be at negative 5 for the function equal to negative 2 to have no solution. Okay. Which means how many times does it cross the line x equals negative 2? Has to cross the line x equals negative 2? No times. And that is it for this lesson.